Hello guys, welcome back to the channel, and this video is a compilation of the entire switch upgrade project that we did at work. In this video, it will be a compilation of the step-by-step and detailed switch upgrade project from unboxing the switch to configuring and what's in the config file, racking, and decommissioning. I will also share my insights on the project, like the most challenging part, least favorite, my favorite, and more. I will also be sharing some tips on best practices on doing the project and the lessons that I've learned when doing this project. So if you're interested in today's video, please keep on watching, and I will also be adding chapters to this video so you can skip parts that you don't want to watch, or you can also skip to the parts that you want to focus on. So without further ado, let's get started with today's video. I'm not sure what the exact count is, but I think it's more than 30 switches that we ordered because we wanted to replace all of our effect switches in the building. So the main goal why we are doing this network switch upgrade is to replace all the fax switches, the old fax switches in our building that has been announced by Cisco that it's end of life or end of support. I'm not entirely sure, but these are like more than 5 years old, and also they are only 10 gig switches. Now we are upgrading to 25 gig. So this is our Cisco switch, Cisco Catalyst 9300 with 48 ports that is managed and stackable and has PoE. So what we need to configure this is a console cable. Just make sure that you're gonna have the proper ports that you can connect to the switch to your laptop so you can access it. There's different kinds of console cables that I discussed also in my previous video. We also need a flash drive where we are going to import the config file for all of the commands that will be running and we will be saving in the switch. So if you are using a USB, make sure that you convert it to FAT32 first. So there's different ways on configuring a switch. You can use a TFTP server and just import the config files from the network. I am gonna use the USB because I think it's faster. I don't have to rely on my network and I don't have to set up my network. I can just plug in this USB to the switch and it will just import the config files quickly. And also just make sure that your Cisco switch supports USB, because some of them you might have to configure to like support or detect the USB. So just make sure that it's FAT32 before you put in the config file and that it supports USB. Also, we are going to need the laptop to connect the switch to the laptop when you are starting our configuration, because we are building this from scratch. It doesn't have anything on it yet, so we need to be able to access the switch. So for now we are not able to SSH to it. We don't have an IP address for it yet. We can't do it remotely, so we will need a laptop for now. And of course, it needs to connect to the network when we are configuring it. So make sure that your network port is, your switch port is configured correctly. If you're going to use trunking, make sure it has DHCP or on the management VLAN and whatever it is that your company has for the configuration to be able to configure this properly. So this is gonna be my first time building a physical switch on my own. I have watched people do it at work and I never had to do it in my previous jobs. I've only configured on simulation like Packet Tracer, GNS3, so I'm kind of nervous actually. I hope I don't mess this up. You won't be able to break it because it's new. We can just start from scratch and probably like flash and wipe whatever wrong config we have if we really mess this up. So it's gonna be a fun learning process. I'm gonna be learning a lot. I have shadowed people who have done this, so hopefully I can do this by myself. Of course, our lab is a mess, but what we need to do first is to plug it in, of course, to power it on. And this is the 2 power supplies for this. And also, realistically, if we are building this switch from ground up, from scratch, from the start, we are not going to be typing all of the commands manually, because that will be probably tedious, and it is faster and more accurate if you just import the config files. And if you work in a bigger company, the config files are probably provided to you by the network engineering team, the networking team. We didn't really create this config file. It was just provided to us, and we will just change it or make changes to it, changing the IP address for the switch and the host name. I think that those are the main changes that we have to do, but the rest, everything will be provided already, and we will just have to import and copy it to the startup config. Okay, so the switch is initializing, and you can hear like noises. I think it's going through the hardware initialization process. Okay, so I'm gonna be using this USB console cable. There are different kinds of console cable. There are DB9 to RJ45. So this is, I think, easier for me because we have the laptop where we need to connect to, and the newer switch, I guess, has the mini USB in front that you can use just easily, and it's plug and play. You don't have to insert like adapters for it. Okay, so before we putty in, let's check device manager first, because we are going to be connecting through the serial port. And if you scroll down to the ports, COM and LPT in here, you would see serial device connected. So this is the port that we are going to be using to connect to our switch, COM3. So now we can putty into the switch and change our serial settings in here to COM3, because that is what we have listed in our serial device. And then go to the session, select serial, COM3 should be selected, and then if you open, you should be able to access the switch and see what it's doing now. So now it's initializing hardware. So we also need what's called an SFP, that stands for small form factor pluggable, and this is a connector that we can use on switches. There are different kinds. There's electronic and optic for fiber and Ethernet, and the one that we're going to use this time is the one that looks like this. It's an RJ45 connector where we can connect our CAT cables so we can get internet on our switch. So the SFP will be plugged in the 2 slots in front of the switch, and you can connect your CAT cable so you can get network. So after you power on the switch, it does a lot of setup like bootstrap, and it checks the backup NVRAM if there's configuration saved to it. It defaults the boot config that is used, a lot of auto installation, and it will ask you to terminate the auto install also. Then after the initial configuration, the switch asked me to set up an enable password for it. And then I will be inserting the USB flash drive now where the config files are, and this will show that the flash drive will be mounted and added to the switch. So we're now able to access all of the files in here. Now I've typed in this command to copy this file. This is the approved OS version of the switch from our company, so it can be installed, and this will be copied to the flash. The Cisco flash memory is what it's used to store the iOS of the software images for the switch. So the only changes that we have to do in the config file is to change the host name. And the command to change the host name is hostname space the name of the switch. And we also have to edit the IP address with the command IP space address and the IP address space the subnet mask. Then once we have edited our config file, the next step would be to copy the config file from the flash drive to the running config. So the command will be copy space USB flash 0 where the flash drive is mounted, and the file name of the config file space running config. Okay, so just a refresher, running config is stored in RAM, which means that commands copied there will be lost after a restart. So after we have copied the config file to the running config, we should also save the file into the startup config so it will be stored in NVRAM and won't be lost after a restart. Now I'm just verifying our configuration by running this command show int status to see all of our interfaces if they were configured. And of course, running the show run command shows us all of the configuration in the switch. We have all of the VLANs, all of the interfaces with their description and configuration. So everything that was in the config file should be in the running config. Okay, so now that I've configured the IP address, I should now be able to SSH to it so we can test it out by puttying into the IP address. Okay, so now it's time to show you the configuration file that we used at work for the switches that we have set up. Okay, so before we get started, just a disclaimer first before you guys come in after me in the comment section that I didn't come up with this switch configuration file. My team didn't come up with this. We have another separate network engineer that have been planning and creating all of the configuration files. We in IT just implement what they have created, and also we report issues and we troubleshoot issues if that happens. So we didn't come up with the commands that were used in the configuration file, and before even deploying the configuration files, we made sure that these were all tested first. Okay, so the first command in the config file is this VTP mode transparent, which just sets the VTP to transparent, and this is allowing the relay of the VTP protocols to be able to be received from one trunk port to all the trunk ports. Next is we are setting up the host name of the switch, and this is where we put our switch name. So usually we have like a naming convention when naming a switch. For ours, it's the company name, the floor, and the rack letter or number, and the actual switch name. And then we are just setting up the domain name, the IP domain name for your company. Okay, next is to generate SSH keys. SSH is to secure our remote access to the switches, and this is the modulus that we are using, and we are setting it to SSH version 2. Next, of course, we are setting up the IP address for the actual switch. Just to take note that I am not showing our actual IP address, so this is just like an example and the dummy IP address, of course. So this is the IP address and the subnet mask. Okay, so we just have disabled a lot of IP commands in here. And then for the next commands, this is to set up the NTP server for our switches. The NTP server is used to synchronize our clocks, make sure that they're always correct in time. Next is setting up the name server. So this is for the domain name, which translates host names to IP address. Okay, next is the banner. So this is what you usually see when you log into a switch. It's just a security warning usually that if there's an authorized access, they will be subject to legal action. So this is usually like a standard for every switch. This is very important. Okay, so the next command is to disable all the web management services in our switches to also prevent security risk, because we prefer like SSH and SNMP to access the devices and not really with like a remote web service. So this is SSH is more secure and we can control it better than HTTPS. I think it's more of like a security practice. Okay, so this is now for configuring the log messages. This is for the system logging, and there are different ways to handle different levels for the messages. I think there are maybe 7 or 8 levels, and we are just using informational in here. Okay, so the next command is to configure VTY. So this is for like remote access and management for our switch. Okay, so the next command is to disable showing the logs in an active session. Console logs are those messages that you see once you have entered the command. So this gets really annoying and can screw up your typing when you're typing commands, and sometimes this just appears when like the interface is up and all. So we disable this so that we can also prevent high CPU utilization, and most of the time it's just because it's inconvenient and it's really annoying when you're typing commands. Okay, so the next is a command for global parameters, and this is just for enabling spanning tree. And here we are disabling this for the HTTP and also enabling LLDP. This is setting up the SNMP server location. So this is just like your company location and where the switch is physically located, like the floor and rack number, and also the serial number for the switch. Okay, also we have like commands for access list. This is just enabling access list, what we are permitting and what we're not permitting. So I'm not gonna go through all of this. This usually is like a long list. So there is our access list. Okay, so next commands are for setting up configuring TACACS. So TACACS is developed by Cisco and it's using the AAA, which is enabling us to secure our remote management and access to the network switch. So once this command runs, we will now be able to access our switches with our like domain username, the same username that we are using to log into different systems. So at least in here we don't have to use the local like the local username and password that we use for Cisco. We can use our domain username and credentials to make it more secure. And now we have the commands for interface configuration, and we are adding like the different VLANs that we're gonna use for the switch. This is just like setting up VLANs and their descriptions in here. Okay, so this is now the commands to configure the core router port. So we have like a port that we configure to be the trunk port in here. So this is for this interface. Okay, so lastly, for our configuration file, we are just configuring all of the access ports, and that's like almost all the ports in the 48 port switch. So we are just doing a range to make it easier to configure all of them at the same time, and then just put them on the respective VLAN that it should have, and set it up as access port, and just disable the SNMP and logging event, and enable spanning tree port fast. So that's how we configure our access ports.
I think the most challenging part for me personally, this is just based on my experience. This might be different from other people's experience, but for me it's racking because I can't do it on my own. I would need help from my teammates to hold the switch for me while I screw it, because I'm not tall enough, and plus I'm not strong enough. I really don't want to drop the switch if I really try to carry it by myself.
So as far as I remember, there is no shutdown command in Cisco. I mean, there is a shutdown command, but that shuts down the interfaces, so that doesn't really turn off or power off the networking device. So as far as I remember, there is no command to turn off a device, just like how we do it in the operating system like Windows, Linux. So I think we just have to turn off the power physically. I'm gonna check on that. Also, best practice before you power off your networking device, of course, you have to save the configuration first. Always save it just to make sure that you have all of the configuration in your startup config when the switch powers on and boots again. So the command to save your configuration is copy, run, start, or write memory. Also very important, if you are racking it, don't forget to label it, put some stickers with the switch name and the IP address. This is really helpful during emergency. If you're in the data center and you're in front of a switch that doesn't work, you don't have to look for switch name in whatever list or spreadsheet or whatever documents you have. You just have the switch name and the IP address. Okay, so I'm now in the data center where we will be racking the switch, and I'm just lucky that there's only one equipment in this rack. So that makes it easier, and I'm just checking where we will physically rack it, and that's the old switch that we will be replacing. Okay, so this bag came with the Cisco switch. This was also in the box, and this includes the screws, the fasteners, and things you might need when racking the switch. Okay, so we do have a bunch of screws of different sizes in here that came with the package. We also have brackets in here. Okay, tip before you're mounting or prepping your switch is to take out the power supply because it adds weight to the switch. And then here is the bracket, and we are gonna screw it to both sides of the switch. This is what's gonna support the switch when we are gonna mount it and rack it. And of course, you're gonna need a screwdriver to screw in all 4 screws to the bracket. Make sure you use all 4 screws to make it super secure. So here comes the fun part now. We are gonna rack the switch, and make sure to ask for help and not to do it alone, especially if you are doing this for the first time. You don't want to be hurting yourself, and you don't want to break the switch or drop the switch or break other equipments that are right next to the switch. So we really have to be careful with this because most of the time when we are racking, there are other equipments right next to the switch that are in production and already working, and we don't want to cause any downtime or outages when we are touching other equipments. Also, if you are replacing an older switch, you should put the new switch at the bottom of the older switch so it will be easy to move all of the connections on the newer switch, and the transition will be easier. Also, make sure to assess the rack and make sure that you have the right size for the screw for the rack, because we didn't have the correct size and we have to do it again because the screw won't fit in the rack. And we have to find the correct size for the screw so it will fit while I'm holding the switch. So just make sure that you have everything you need before you actually screw it in and mount it, so it won't be a hassle when you do this. Okay, so I forgot to film this, but you should put the power supply unit back to the switch so we can plug it into the power strip. So here's best practice. We have 2 power supply in the switch, and we're gonna have 2 power cables. So we need to plug in both of the power cables on each side of the rack because one goes to the main power and one goes to the generator or the backup. So at least if there's a power outage, our switch can still run on the backup power. Okay, so when we are patching the switch, we are going to need the SFP or the small form factor pluggable, and this is a modular slot where we can plug in fiber optic cable or a copper cable. So there's different kind of SFP we have for the Ethernet, multi-mode and single mode. We are going to use the single mode, and it looks like this with like 2 slots because we are going to be using fiber optic cable for the switch uplink. So this is what it's gonna look like now. The switch was racked and we have inserted the SFP. We used 2. So we've also plugged in the fiber optic cable to this, and now we are gonna patch it to the patch panel, which I'm gonna show you later on. But this is what it's gonna look like. It's inserted in the 2 network module in front of the switch. So this is what our patch panel looks like. It patched both of the fiber cable, and this is gonna be patched into where the router is. Of course, when we're racking a switch, we have to connect it to a router, and it depends on the company where the router is gonna be. Sometimes it's in the same data center where the switch is. In our case, it's on a different floor from where the switch is racked. So I went to the other floor and patched it in to the patch panel, and then I will be patching it to the router itself so that it can connect from the switch to the router. So this is what the patch panel looks like, and I will be punching in the fiber cable to this, and this is our fiber cable. This is usually covered with this little white cover that you can see in here, so we have to remove that, and now we can plug in our fiber cable here. Just make sure that it clicks on both sides. That means it's punched properly. So here is where I patch it in the other router. Here's the patch panel, and it will just plug into the router here on top.
My least favorite part is migrating the cables from the old switch to the new switch, because for me that's more nerve-wracking than configuring the switch and racking it, because if you misconfigure the switch, since it's a new switch, you can always start again or start from scratch or just reset the switch because nothing is affected in production. But if you're migrating and moving it over to the new switch, sometimes stuff happens. There can be issues with the new switch. So it's really more nerve-wracking, and that's my least favorite because it's more stressful. And of course, when you're doing projects, it's not always perfect and it's not always smooth as everyone would hope it to be. There are times that you'll encounter issues, and that is completely normal, so don't panic, especially if it's your first time doing a Switch project or any other project. It's completely normal, and that doesn't mean that you didn't do stuff properly. Sometimes stuff happens and we have no control in whatever issue, so it is fine, and it also tests our troubleshooting skills on how we will fix those issues. So during this Switch deployment project that we have been doing at work, I have encountered 2 Switch issues so far from different switches, and I'm going to share with you how I fixed it and what commands you can use and how to identify the issue, how to rule out all the other issues and narrow it down to the root cause of the problem. Of course, there are different troubleshooting methods that we can use, but for me personally, I always rely on the fundamentals, which is the OSI model. So there are also different approach in which we can use the OSI model. We can do the top-down approach, which means that you start from the very top layer, which is the application, down to the physical. Or you can use the divide and conquer approach, where you start in the middle of the OSI model, and then based on your findings, you can move up or down the OSI stack. Then the last approach is bottom up, where you start from the first layer, which is the physical, going up to the 7th layer. So in the Switch issues that I've encountered in this Switch upgrade project, I'm going to use the bottom-up approach because it starts at the physical layer, and during the project we are dealing with physically cabling and physically racking the device, and it makes sense that we start from the physical level during troubleshooting. So let's get started with the issues, and let's get started with the easier issue. So the first issue is the server connected to the new switch isn't working properly and not getting the right connectivity. So this was reported by our engineers, and they moved the cable back to the old switch and it works there. They only moved 2 cables because the rest of the ports are working on the new switch. Okay, so let's go back to our OSI model and let's use the bottom-up approach. So let's start with layer 1, or the physical layer. So they said that the port is lit when the cables were plugged into the new switch. So that meant that the port itself is working and it has connectivity, and also when it was moved back to the old switch, everything on the server is working, so there's nothing wrong with the cables as well. Okay, so we are done checking the physical layer and we have ruled out that there's nothing wrong with the physical aspect. Let's now move on to the next layer, which is the data link. So this is where we are going to access the switch and check the configuration. So next is I'm going to compare the configuration from the old switch, because it is working there, and to the new switch, and see if there's any difference. The easiest configuration that can cause an issue is wrong VLAN. So I'm just going to compare the old switch from the new switch, and to get this result where you can see the interface and the VLANs easily, I just typed in the command show int status, and you should be able to just compare the old switch configuration to the new switch. So this is where I found out that there's a VLAN mismatch indeed, and I had the wrong VLAN on the new switch. And sometimes that happens and that can be skipped or missed. So the fix for this is pretty simple. Just configure the switch port to the correct VLAN by doing this commands, and that should fix the issue. So for the next issue that I had, it's the second port of the switch is not working. So this was a tougher one to fix, and it took us probably days to resolve this issue, even if it was simple in the end. So when we rack the switches, we connect them to the core router on different floors in our building, and we use fiber cable to connect them, and that serves as a trunk port to our switch. And the issue with this one switch is that one trunk is working and one trunk is not. As you can see in here, the second trunk is not even lighting up.
So let's go back to our OSI model and use the bottom-up approach and start with the layer 1 physical layer, because the port isn't even lighting up even if the fibers are plugged in and patched in to the core routers. So we tried so many fixes and solutions for this until we have narrowed down that it is not the physical issue, or we have fixed the physical issue with this. So these are the things that we have tried doing. So we flipped the fiber cables on the switch and the core router just to make sure that it wasn't a cable issue. Then we moved to a different patch panel just to make sure that the patch panel that we have plugged into isn't the issue. Then we swapped the fiber cable with a new one just to make sure that the cable is working. Then we swapped the SFP with a new SFP just to make sure that it is not the issue. Then we moved the working SFP and fiber cable to the non-working port, and it's working there. So it means that there is an issue with the patch panel or the router that I am connected to on the second port. Then we swapped the network card on the switch just to rule out that the network card is defective. Then I asked our engineers to clean the fiber cables and also to test the connection of the patch panels and make sure that they are working, and they even brought these amazing tools with them and they've tested that everything is working. So we have tried basically everything that we could and ruled out that there is nothing wrong with the physical layer. Now we can move on to the next layer, which is the data link layer. So this is where I check the router for configuration for the switch ports and see if there is any mistakes or there's any difference. So the one on top is the current switch trunk configuration, and one at the bottom is the router port configuration, and I'm just comparing if there's any difference and see if they are both configured as a trunk port. So this is where I found out that the speed for both the ports are different, and that is a speed mismatch, and that definitely causes connectivity problems like the trunk port issue that I'm having because they are different speeds. So our network team is usually the one configuring the router, so they have hard set the speed on this instead of doing an auto configuration. That's why there's some mismatch. So in this case, the resolution is to just set up the speed as auto, or if you want to hard set it up as matching speed to prevent the issue.
My favorite part, I think my favorite part is configuring the switch, because this is where we learn the commands and it's really fun doing it in action on a physical switch. And also one of my favorite parts is decommissioning, because it means that the project has been successful and you can now retire the old unit or the old device because a new device has been successfully deployed. So that's my favorite part as well.
So decommissioning a device in IT refers to the process of permanently removing it from the active service and retiring it from the network or infrastructure. So decommissioning is probably my favorite part of any projects, because it means that the project is almost complete and that you were successful in upgrading a device, because you're taking away the old device now, which means the new device is now in production, it was successfully installed, and no more issues were encountered. So here's the best practices when you decom a device. Before decommissioning, once the new device was deployed, leave it online for a few weeks just in case there's an issue with the new device. Then after a week, shut down the device but send an email to your team first to give them a heads up. So here's an example of the email that I've sent to my team. Of course, the subject is to decom the switch and which location, and the message is just brief. I'm just letting them know that I'm decommissioning the switch, and if there's any objections, just let me know before I unrack it. So next step is very simple. Just unplug all the cables connected to it, power, fiber, and also unscrew the mounts, and just ask for help if you think that you can't do it by yourself. It's always better to be safe and not to damage the rack and the equipments. Also, decommissioning is not just physically removing the devices where it used to be. It's also like removing the device from different systems like DNS, your inventory, removing it there, so you can also clean up your assets.
For the tips, I think if you're doing this for the first time, just remember that it's okay if you mess it up. Don't be too nervous. It's okay to be nervous because it means that you will be very careful in doing it. And it's really okay to mess up a new device because you can always revert back to the previous settings, or you can wipe it and start fresh again because nothing is deployed in there. So it's okay to make mistakes, because when my team was configuring the switches first, we made mistakes and we reverted back to our changes. So we made a lot of mistakes when we were starting, but the good thing is that these are new devices and you can always start fresh and wipe it. Also, another tip is communication is really essential when doing projects like this, especially when you are deploying the switch and migrating. Always over communicate, then not communicate at all. It's really important to cover your bases, send a lot of emails that is necessary, especially when you are migrating to the new. Let everyone know and give them a heads up that you're doing the project, so just in case there's an issue, at least you know, or they know that there was a change that happened. Lessons learned. So this is my first switch upgrade in production. So I learned a lot of things, and one of the most important, I think, and overlooked lesson that you can learn is to be a team player and learn how to work with other people and learn what teamwork is, because projects like this, if it's a huge project, if it will affect production, most of the time you won't be able to do everything by yourself because you have to work with other people, coordinate with other people, especially when like racking, just like me, it's very challenging. So you need to get along with people so they also would help you do your task or accomplish your task. Also, another lesson learned in this really big project is planning is the key. So in order for everything to be properly set and organized, you really have to plan everything before start the configuration. So we do have a spreadsheet with all the necessary information that is needed in this project. So it will be more organized and it will be easier when we get to the configuration part, and everything is communicated well. So you really have to plan ahead on what the switch name will be, the IP address, where you're gonna rack the switch before you even do configuration and racking. Okay, so that's it. That's wrapping up this switch upgrade project. It has been, I think, 6 to 8 months of all the hard work, and thank you so much for joining me since day one, since we unboxed this switch until decommissioning. Now, I've compiled everything, so it'll be easy for you guys to watch it if you want to watch everything from the beginning to end. So I hope you learned something from this video, and I really hope that you enjoyed watching this. If you also have other tips, please feel free to leave it in the comment section down below. I would also be happy to learn stuff from you, especially from seniors. Thank you so much for helping out in the comment section below too, and I hope to see you guys in the next video. Thank you so much for watching.